right, it shows that we're live, which is a good thing. So, just gonna make sure we're good on YouTube. All right, everyone. Welcome to this evening's misec presentation with our friend Jason. This is the Lansing misec presentation where Jason is going to be doing an amazing showing of how he can embed malicious code in images and execute them in a very unique way, further than you thought. Tonight we'll have also presenting with us Brian. He's going to be our ultra champion, major league baseball player of all kinds and everything for Lansing leader. He's right here in the middle corner, and Jason will be our presenter. So Jason, without further ado, you can take it away. Thanks, buddy.
Thank you so much. So like I said, my name is Jason Caminsky, and we are going to be talking today about how we can smuggle malicious code in through images and also other media files. So a couple things about me to start. Currently my day job, as I call it, is I'm a cyber threat analyst with Centene Corporation. My role these days is primarily threat intelligence, but also a bit of threat hunting and a bit of threat emulation as well. So I tend to spend a lot of my days trying to learn what the bad guys are up to, how to approximate it as best I can, and how to hopefully find signs of it after the fact. But in my free time, I'm also an independent security researcher. I have a number of bug bounties to my name, and I like to try to keep busy with various security projects. Sometimes inspired by stuff that I encounter at work or online, or sometimes just random ideas that pop into my head, such as this one. My primary interest in information security is the intersection of human behavior and technology. I like to think about how people design technology versus how people use that technology, because oftentimes there's very interesting kind of misalignments between those two personality types. I also like to think a lot about how team and organization structures kind of impact how technology is used and also how it's designed, things like that, and how different organizations interact with each other. There's a lot of just really interesting overlap when you can kind of jump back and forth between, the code that's running on a machine and the thoughts that are going through a person's head, making use of that code and acting and reacting to what that code does. I'm also a guy with quite a few hobbies. Among them, I am a singer and musician. I absolutely love karaoke. Now that the bars are opening back up, I really look forward to getting back to that and hopefully seeing folks out there. I also like trying and making interesting cocktails, speaking of which. I'm also very much into tabletop RPG design. I like to make my own little games that I run for my friends as much as they tolerate. And you can see right there, that's the cover of one of them. Ended up doing well enough I was able to actually get it published. So those are kind of some of the things I like to keep busy with when I'm not just working on information security stuff. All right, so let's lay out what we'll need to understand before we get to the demonstration of this. We'll need to understand how systems determine file type. Then we'll need to understand how we can use that to hide malicious code in a non-executable file, and then, importantly, get it back out again. And then we'll kind of explore some of the implications of this before we get to a demonstration of one particular use case that I would envision with this. One thing to keep in mind, most, if not all, of what we cover here is probably not going to be super complicated or really new to any of the folks that are interested in this kind of stuff. This presentation, and actually, a lot of my security research I tend to find, focuses more on finding kind of interesting and unexpected ways to use existing technology. If we were to get metaphorical with it, I would say we're not really creating any new words here. We're using a bunch of regular words to say something new. So with that in mind, if we had a live audience here, I would solicit answers from folks out there in the world. But in this case, I'll just invite anybody watching here to take a moment to kind of think to yourself about the various ways that we might determine, what a file type actually is for something. Typically, the first thing that occurs to people is extension. A lot of IT administrative scripts are based on the idea of looking for files, star dot whatever extension you want to find in whatever server directory you're doing. Even a lot of malware and ransomware functions this way. If you've looked at analyses of different types of ransomware, one of the things you'll usually see in there is a list of file extensions that are excluded from it. So this is very much something that we rely on. And they can get pretty interesting. There's kind of an endless assortment of them. But the thing to keep in mind is these aren't really enforced. I mean, they're sort of enforced. They're enforced in the Windows GUI. If you double click on a TXT file, for instance, in Windows, it'll try to open it in a text editor. If you double click on a exe file or anything else with a extension that is considered executable, the system will try to launch it. But other than that, it's purely a matter of convenience. You can execute any file with any extension or no extension from the command line, no problem. So you could very, very easily just execute a .anti-disestablishmentarianism file. There's no reason you can't. If you think about that, it really makes sense, especially if you're used to working in a Linux environment. For that, what makes a file executable is just a flag on the file. But it's interesting how often we tend to overlook this in a lot of investigations. People will, their first inclination tends to be to just sort of see an extension and kind of take it for granted. We really need to break this habit, both when considering a situation like this and also just, in general with our security work, because really, I mean, a file extension is nothing but a part of the file name. If you can change a file name, which is not, a restricted permission or anything like that, you can change the extension and make it whatever you want. So we really shouldn't rely on that as a reliable indicator of what's in the file, but we often do. Another thing that might occur to people is MIME type. So that is media type, aka MIME type. It's basically it's a two-part identifier. It's used to kind of label data that's transmitted across the internet. Anybody that's worked with like Burp Suite or any similar such software and is used to looking at HTTP requests and responses, you've no doubt seen these. They get there's a header that conveys this back and forth. So there are a couple examples of some common kinds. If you really look into it though and try to figure out like how is this determined, what information does what look at in order to decide to label it multi-part form data as opposed to text plain. There are a variety of methods for that. Different pieces of software will use different methods. Like for instance, if you go to upload a file via Chrome, Chrome has a section of code that has a whole list of ways that it uses to determine what MIME type to give to that file when you upload it. Web server software, same thing. If you request a resource from a web server, it will go through a bunch of processes to determine what that label should be. But ultimately, none of these are reliable. First off, most of them rely quite heavily just on file extension, and they're variable. Like you can't depend on these to be authoritative in any way. Ultimately, this is just user input, and as we know, user input cannot and should not be trusted. So this is also not a good way to determine file type either. So rather than belabor this point further, I'll just give you the answer. The answer is something called magic bytes. You can see here this screenshot. This is what you see if you open up an executable file. So magic bytes are blocks of byte values at the start of a file that signal that file type to application and how the subsequent bytes should be treated. There's a whole variety of them. Here's some common examples. Executable files start with this MZ. JPEGs start with this sequence of bytes, and so on and so forth. There's a large variety of them. Wikipedia has a pretty exhaustive list. I'm sure you can find other ones as well. But ultimately, this is the most authoritative way to do it. This is what the file command in Linux does, and this is what whenever an application attempts to interact with a file, it will check the first bytes to determine what kind of file it is, and to decide what it can and can't do with it. What is important to keep in mind is if we can modify file contents. If you have sufficient access to the file, or if you're creating the file yourself, you decide what's in that file, and that includes deciding what these magic bytes are. We can modify them, we can change them, we can add a blank line to the start of the file so there are no magic bytes. We can swap out the magic bytes for one file type with that of another while leaving the rest of the file contents the same. Now, we have to be careful about doing this, of course. If you change the magic bytes, most of the time you're just going to corrupt the file. For instance, if we change the magic bytes of an executable file to those of a JPEG file, Windows, if you open that then in a image viewing piece of software, it's going to try to treat it like a picture. It's going to very quickly discover that the data included in there doesn't make sense from the perspective of an image, and it's going to error out on you. But there are ways that we can take advantage of this in order to fool things that nevertheless rely on this method of determining what the file type is. So let's keep that in mind for a minute, and now let's touch on the next bit that we'll need to understand as we move towards this demonstration. So combining and separating files, file contents are just a sequence of bytes. That's ultimately what a file is. It's just a segment of bytes that we're considering. The file length is just the number of bytes in that file. So when you look at a directory listing and you see the size of the file, that's expressed in bytes, and that's what that corresponds to. So if we were to say, for instance, file C equals file A plus file B, so we basically take file A and we append file B to the end of it and call that file C. What we can do is, if we want file A, we start with file C, and then we basically take the total length of file C minus the length of file B, and then we just take the first bytes of that difference, and that corresponds to file A. If we wanted file B, we would take file C and we would just select the last number of bytes equal to file B's length. So this is very easy to do. This is very simple, piping and redirection on the command line. It's so simple. It kind of seems silly to think about it this way, but it really is that simple. You can simply stick two files together. They'll be considered one file, and you can pull them apart again if you know the exact length of each one, and you can basically, pull out of that file that number of bytes and stick it into a new file of its own. You're not changing anything. So what happens to magic bytes when files are combined? We should ask ourselves. Well, if file C equals file A plus file B, then file C's magic bytes equal file A's magic bytes. So if file A.jpg is added, if we append to the end of that file B.exe, then the ensuing file C will be considered a JPEG file by anything that looks at it. What this means is file B is obscured. Its contents, including its magic bytes, just start randomly somewhere there in the section in the middle of the file. And unless you have reason to examine the file contents in detail, something like a YAR rule or some greater degree of scrutiny than is typically paid to random files whizzing around networks, you're not even going to know that the one file that you're being presented with is 2. And you're certainly not going to know where in that file to start looking because the beginning of the file is much clearer than the end of the file. So in a sense, we're kind of spoofing magic bytes. We're falsifying the magic bytes of the file that we want to hide within another file. But it's more than that. We're adding an entire valid file in front of our malicious payload. And what's interesting about this is the functionality of that file is retained. If you take an image file and you stick an executable file to the end of it, that image will still open and render just like any other image. Like there's no error messages, there's no indication there's anything unusual about it. If you happened to know the original file length of the original image, obviously the length of the image would be greater. But, generally speaking, when you get a random image, you don't know, you have no reason to suspect that the size of the file that you see is not accurate. Furthermore, this also works with other types of media files as well. You can use MP3s, MP4s. And those, the file length, it becomes, anyone's guess. Like, nobody is going to suspect that there have been, a couple of kilobytes added to the end of an MP4, and that is going to be the thing that tips your suspicion. So let's think of some of the scary implications of this. What if we were to create a spiked image file with executable code added to the end, along with some sort of label hidden there within the file? We could use a file hash, we could use a random string, anything. We could then host or distribute that spiked image on whatever sites we can think of, photo sharing sites, blogs, send them to random people and hope that they do something peculiar with it. Anybody who looks at that in a browser, that spiked image is going to get cached in that browser automatically. And users may also download it. It may also end up in various other places on the person's computer. But basically, it'll be treated as a fully functional image, and images get to all kinds of places, especially if you make a catchy one. Imagine if we did this with a popular meme. You then send out into the world a first stage dropper, and that could be anything. It could be a malicious macro. It could be an executable file that has, some useful or benign function, but then also has kind of a hidden function where it looks through, browser caches or various other places on a file system for any image that includes a tag that it recognizes. This could happen via, some sort of browser vulnerability that's triggered upon visiting a website. And then that dropper basically searches for an image file that has this executable code hidden within it, extracts it, and then executes it. What's interesting about this is basically obtaining a secondary payload without a call to a C2 server. Typically when, if a person, executes, a malware loader or a dropper or anything like that, there is, an immediate step where when it executes, it calls out to another server, and that becomes very clear. Like, we look for this sort of behavior in network traffic in order to determine the presence of malicious files. In this case, it's not calling out at all. What it's doing, it's searching for a secondary payload that's hosted locally. That payload may have been downloaded days or weeks prior, possibly without any direct user action, possibly passed around between people within an organization, distributed, all over the place. You don't necessarily have control over where it ends up, but it spreads very organically. And all you need to do is get it somewhere on a machine that you can consistently look for. Essentially what we're doing here is we're turning kind of one sketchy action, that would be a user executing a file and that file immediately going and grabbing a secondary payload, with two less sketchy actions. We are executing a file that in and of itself doesn't do anything bad, and we are downloading an image, or better yet, caching an image, just in the course of our normal web browsing. So if we hide the dropper in a benign or useful file, it only becomes malicious in the presence of a spiked image. So basically, neither one of these gives away its presence in isolation. Another thing that's nice about this is it's infinitely repeatable. As long as you know the label of the spiked files and you know the length of the original payload, you can basically take as many swings at this as you want. You can create an infinite variety of droppers. You can send, countless different modalities, basically. Like you don't have to rely on getting your malware in there via a macro, because a lot of organizations they may block macro attachments. Instead you can rely on some other method. And if one of your methods gets found out, even if people know what to look for, it's going to be very difficult to review the contents of literally every single file looking for a particular key value. Like that's just not feasible, because you would hide this really in any type of file. We're focusing on images for this, but yeah, any media file, really, like any file at all. So it becomes very difficult to root this out. Kind of one of the analogies I thought of, speaking of tabletop RPGs, one of my favorite tabletop RPGs, it's the samurai themed one. And one of the games that I ran was based kind of around court intrigue, and there was an assassination that happened. Person without anything unusual happening to them suddenly dropped dead in the middle of this moment of high drama during a feast. And the idea behind it was the assassin had studied their movements and had learned like all of the different things that they liked, and they had hidden a multi-stage poison in each one of those. So it's kind of like imagine if you put part of the poison in the cornflakes at a grocery store, you put part of it in the bubble gum at a gas station, and you put part of it in the whiskey at a bar. If you know that there's only like one guy who routinely does all three of those things in the course of a single day, you can basically broadly distribute this, cast a very wide net, and still count on your target being the one that gets hit by it. So that's kind of the thinking behind this. So with all that said, let's go ahead and move to a demonstration. But before we do that, were there any questions about anything that we've covered so far?
So far, I don't have any demonstration questions or any presentation questions at the moment. It looks like on YouTube or on Twitter that I've so far seen.
Perfect. I'll assume that that's because it's so perfectly clear. Okay, so let's get to it. Give me a second here to get situated. Okay. So here we are. We've got a directory here with a list of files. So let's talk about what each one of these represents here. So calc.exe, this is basically going to represent our malicious payload. In reality, this would of course be something a lot more insidious, but for this, basically we'll treat, for the purposes of this demonstration, if a calculator opens up after what I'm going to do is done, that will indicate that we were successful in getting malicious payload smuggled in with our image and getting it to execute. This picture is a picture of one of my custom cocktail creations, but it's also going to serve as our spiked image. Right now, this is the original one that doesn't yet have the malicious payload added to it, but this will be what we add it to. This right here, smuggle_exe.ps1, this is a PowerShell script that will stand in for our useful/benign executable that has legitimate functionality, but also has our file search and extraction process entered into it. We'll take a look at the code at that before we proceed fully, but that's what this is. And then smuggle.exe, this is basically just a .NET executable. It's this compiled. All right, so let me, okay, good, we got our web server running. Okay, so the first thing we're gonna do here is we'll add our malicious payload to the image. So this is a two-step process. First, what we're gonna do is we're gonna take the SHA-256 hash of our malicious payload. We're gonna use that as our label. In practice, we wouldn't have to use that hash as our label. We could really use anything. We could use a random string as long as we keep track of it. But for this, a hash is a nice, easy way to do it. So the first thing we're going to do is we're going to find the hash of our calc.exe, our malicious payload, and we're going to append that to the end of the image. And then we are going to take the contents of our malicious executable, and we're going to append that to the end of the image plus the hash. So we'll get here a before. And an after. You can see length has changed. We'll also note the hash that was added. So this is the hash there. And we'll also take note of the length of the malicious executable. Now, I've already included those in the attack script that we'll use here, but these are two pieces of information that we would need to save when we're creating these spiked images. So let's go ahead and take a look at this script that we're going to be running here. So this is our image smuggler script. We have the legitimate function that happens here. It's basically a nice reassuring IT process that we can run in order to check basically the most recent file in a directory that we're monitoring. So this serves to represent something that some system administrator who is pressed for time, looking through some tech forum, finds this program that can monitor a directory and decides to use it without looking too closely at it. And yeah, as we'll see when we run this, it'll give us some useful information and some moral support. But more importantly, we also have this whole bit here. So let's step through it. First thing we have is our key. This is the SHA-256 hash that we calculated earlier, and we have the payload length. So this first bit here, we're basically just creating a little sort of mini database that matches the key with the length. Now, in practice, we could basically add as many keys and lengths as we wanted to this thing. So, we could spike a whole ton of images and put different keys in there. We could spike them with different payloads. This fully supports that. In this case, we just have the one. But yeah, this step is basically just to kind of organize that for us so that we can, kind of systematically look for any of the ones that we might embed in there. Here are the paths that we're going to look for instances of our spiked image in. So we can see this is basically the cache for Chrome, cache for edge, the user's download folder, their picture folder, music and video folders. And you could, realistically, you could add whatever you wanted to these. These cached ones are very nice though, because simply visiting a website, it will automatically cache those images, and those tend to hang around on machines for, sometimes quite a long time. And then this section, we basically go through each of these locations, look for any instances of a spiked file, and add it to our collection of them. And here, if we didn't find anything, the script just silently exits and doesn't do anything else. So this is nice. It means a person can repeatedly run this file over and over and over and over again, and it won't do anything weird. So the legitimate functionality, its credibility is increased because people can use it and nothing bad happens. But if it did find a spiked file, it will basically go through and for each one, figure out which one it is. It will generate a random name for it. And in this case, I basically drop it into the download folder. You could make it spit the file out wherever you wanted. Download seemed a nice place because users often do download things, and a downloaded image isn't going to be inherently suspicious. Also, just to emphasize the point that we can execute .jpeg files or really anything we want, our dropped executable is going to have a mismatched extension. So then what we do is we take the content of the spiked file, and then we drop the sequence of bytes equal to the end of the file, the number of bytes from the end of the file equal to the payload length that we use. And then this bit here, we just execute it and then immediately delete it after the fact. And then this last bit here, this is just a little bit of cleanup. What we'll do after we've executed the malicious payload is we will go back to the image that we pulled this from, and we will basically purge the malicious payload from that image. So if somebody comes back after the fact and looks at the image, there won't be any malicious code defined. It'll just be completely clean and purged. All right. And then the last thing we'll need to do is make sure that our spiked image has been copied to the web server directory that we're using. All right, so the first thing, let's go ahead and run our executable just normally. Let's say we're, IT administrator, we just started the day, we're feeling down, so we want to check the contents of our file and we want a little boost. So there we go. You can see there, hey, it's this date and time, and we're awesome. Oh, that's nice. I like it when computers are human. Most recent file in our monitor directory is this. It was written at this time. Sweet. We'll definitely do this again later in the day, both to do our job and also to top up on moral support. And as we see, nothing bad happens. Nothing executes. No alarms are triggered. Nothing bad's going on. So we might say we've been doing this multiple times every day for several weeks, and this file has been deemed to be safe. But then, we hear about this, this craft cocktail event that's happening at a bar nearby, and we decide, oh man, I want to check that out. And one of the people in there has a link to a website with their portfolio. Some of the drinks that they've done in 2021 so far, and maybe we want to see what kind of stuff we have to look forward to when we go out to this. So we click on the link. See here, oh man, look at these. Oh, these all look good. Can't wait to try them. All right, so we've done that. We haven't clicked on anything. We haven't downloaded anything. We haven't interacted with this in any way. So we make a mental note, make plans with friends, and then we do a bunch of other stuff throughout the rest of the day. But then, afternoon comes, we come back from lunch, and we're feeling bummed out again. And we also need to check the contents of this directory. So we go ahead and we run our script again. Cool, okay. Changed, more recent. It's really nice that it says I'm awesome. I very much appreciate that. Cool. Okay. So now, let's see what happens. And hopefully I sacrificed enough goats to the demo god. Yep, there we go. Our malicious payload is executed. So you can kind of see how something like this might occur. And this is of course only one instance of it. In reality, this could happen in any number of other ways. Some sort of dependency compromise, for instance. Say there is some application we rely on that uses kind of different portions of code taken from many different sources that we update frequently. An attacker gets into one of those repositories and compromises one of the dependencies for something that can very easily get incorporated into an environment. And most people won't notice because, in a great many places, it'll function completely normally and nothing bad will happen. But if a person has also gotten one of these spiked images on their machine somehow, it will find it and it'll execute it. And it will be a mystery as to what prompted that. It's not that it will, it's not that it's, impossible to sort of backtrack what happened, but it's going to require a few leaps of logic that are not typically where an investigator is going to think to look. It's also nice on this because you really can just take your time. You scatter these to the winds, and then you just sit back and wait. This is an excellent way for kind of less targeted attacks to work. But even if it's a targeted attack, because you have the option of using a bunch of different kind of modalities of this, you can basically be very aggressively targeting an organization, and it won't be clear that you are, because it's not that you're sending a large amount of spam emails to them. For instance, you might send a cluster of spam messages. You may also put this image on a bunch of websites that their user base are likely to make use of. You can basically, you can put this in any number of different types of files, and you can hide the dropper in any different number of formats. And all you need is one crossover in order to get your execution. So that's kind of the possibilities that open up as a result of something like this.
Yeah, I was thinking about it. Like, one way I was thinking you could use it is like, because like especially if you appeal to someone's vanity, you know what I mean? Like they want to see a picture of themselves, and you could be like, hey, we saw you spearfishing wise. I saw you. We have you at this event. We want to use it a promotional picture. However, we want to get your permission to do it first. Can you please check out this promotional picture? Provide a link or whatever. And it shows like it's going to the legit place. Spoofing or whatever. And then all of a sudden it's like, it is literally a picture of them maybe, because if you're that that advanced, and then it's like, hey, thanks for stopping by the way. Execute.
Exactly. Yeah, totally. All very possible. Yeah, in fact, hiding something like this in like a faux marketing campaign would be an excellent way to do it.
Yeah, seriously. Yeah, because it could even be more general. It doesn't have to be so spearfishing at that point, because it's just definitely like very, very broad. But at the same point, so we did have one person write from our Discord channel, and it was from Nerd Woman. She wrote, "My favorite mixed drink is Dr. Pepper and Malibu, and it needs a cool name or something, though," is what she wrote. So like, but that was my question. Yeah, and I was thinking about actually asking you, like, what's your favorite cocktail that you make? Before we get
My
into
favorite, yeah, no problem. My favorite to drink. It's not like a fancy one. Kind of like this technique. It's tried and true. But it's old fashioned is probably my go to. That's what I got right here. Maple syrup old fashioned. It really does the trick, man.
No, do you like it? So then you like them to be sweet, or kind of like how do you prefer them?
I tend to prefer boozy cocktails. I'm not afraid of the taste of alcohol.
Yeah, I'm kind of a wuss. I can take it and test it. Like I can just taste it and everything, and I'm like, yum 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 yum. But my wife's over there and just like she'll like have a tequila shot and be like, "You got more of these?" It's like, man, you're powerful. You know, she's just, man, it's good. So I'm kind of curious, actually, if we can jump into the questions that I have for you.
Yeah, absolutely.
Okay. So I noticed that this was really based on PowerShell. So I was wondering, how much do you interact with Windows, like on a daily basis?
Me personally,
Yeah.
quite a lot. Like many large companies, we're a Windows shop. So most of my daily tasks occur in that environment. Most of my kind of independent work, I typically work in Linux. Kali,
Yeah.
like many similar such people. I would say, I focus this primarily on PowerShell because I would envision that being the primary vector with something like this, because this really is targeting kind of general users in a lot of ways. The same principle would probably be perfectly viable via Linux. I would say it would be hard to make the same file sets necessarily cross-platform, at least the dropper portion. The images, sure. Image files or whatever you hide the malicious code in, as long as it's something that's viewed via browser or anything like that, it basically works the same way. And you can certainly include Linux like browser cache paths and all of that. That wouldn't be hard at all.
Yeah, because that's what I was thinking about for Linux. Yeah, because I'm thinking like in Linux, people will use Chrome. A lot of it's very Chromium based, browser based. So I was thinking like if you could execute that, and then how that would be able to be applied in that sense for Linux more easily.
The trick that you would need to include the step of making the file executable, though, which in some ways might be a little trickier. Windows is kind of a little easier in that respect because as long as the byte sequence is, one that can be executed, as long as you can write a file to the location, you can execute it.
Right.
Whereas depending on kind of your permissions and how that's working in Linux, you would have to add that step of making the file executable, which might be blocked, or that would be a point at which what you're doing would be a bit more obvious.
Right. Yeah.
I could very easily see, that being a basis for detection for something like this. Look for, just any files being labeled as executable that shouldn't be.
Yeah, I would imagine like Linux, for example. I remember, I think it was last year. There was I think it was an extension-based issue in Linux, but it was really specific to a specific use of Linux systems that was out of the Ukraine coming from Russia. So when I think of Linux, I'm thinking more, it's along the line of being a very narrow view, because Linux is so hard to attack, and you'd have to really know the group better. So I think it'd be more like narrow and spear phishing almost, in a way, like even broad spear phishing. I don't know what that term's called, but we went with it.
Yeah, and also, I mean, there is. I would suspect that there's probably going to be, I mean, in some ways there's less variability in Linux, but in some ways there, from like a user perspective, which this really capitalizes on. This is ultimately an attack on user behavior. I would say from that perspective, Linux is probably going to be more varied, which means it's going to be harder to generalize this, than it would be in a Windows environment.
Right, exactly. Especially since more general office personal use systems interactive for especially GUIs is going to be hardcore Windows based. So it's definitely go where the marketing is if that's your goal. So
yeah.
So you mentioned you've submitted a couple CVEs and they were approved. I was kind of curious, what were those?
So they're bug bounties. Unfortunately, none of them were earth-shattering enough to warrant a CVE entry. But yeah, I do have a couple. I have one that was in Confluence. I have one that was for some budgeting software that allowed attacks of some fairly major banks.
Oh.
A couple things like that, and then some more low-key ones. Bug bounties are kind of interesting. The ones that tend to be the most interesting, like this has certainly changed today. Like I would say the payouts for bug bounties are a lot nicer now. Like people that really put in the work, you can get a decent reward. When I first started doing it, the rewards were pretty paltry, and a lot of times you would put in a lot of work for not that much of a reward. So people tended to work more based on volume rather than kind of depth. And for me, it's very much curiosity that kind of drives me to work on this sort of stuff. So yeah, I tended to be more interested in using it as a way to learn more about the underlying technology and to just kind of find like neat things that you could do, as opposed to necessarily turning it into into a consistent revenue stream.
Right, and definitely this presentation is exactly that, showing too, because like this was like you said, you found this based on curiosity. You're like, do these go together? Hey, that's like
yeah, exactly.
So
one other implication of this that I do want to mention. So we focused on kind of an attack scenario. Another thing though that tends to result from this. There are a lot of security controls that do rely on file type. Like, for instance, a lot of companies have proxy policies that will attempt to restrict users from downloading certain types of files. And some companies rely on this more heavily than others. I have certainly seen companies that rely on this very heavily. They consider that one of their major security controls. Generally speaking, this will bypass any of those proxy controls. And it really makes sense when you think about it. I mean, proxy, imagine the overhead if you were to fully examine the contents of every single file that came through, and how would you even look? What would you even look for? There's a couple of signatures that you could look for, but those are very easily obscured. In this case, we literally just grafted a straight executable file onto the end of an image. But in practice, you could encode that. You could do all kinds of things in order to obfuscate it. That would make it essentially impossible for any security appliance that is looking at file types to spot. So the implications of this for smuggling files onto or off a network, if there are controls based on making assumptions about the type of file. That was also something I did want to mention.
Yeah, and I thought about it, like, since you mentioned that too, it kind of makes me kind of go full circle with the idea that, your best defense is your frontline people, so it's like you can have all the systems in place, but it's much like a car, like you can put a seatbelt in, you can put airbags in, you can do all these amazing things for the car, but if the driver's going to be crap, it's going to be crap. But if you teach the driver to drive well, they're less likely to drive poorly. So it's much like in technology. It's like these users, especially my experience is like a lot of users will go, oh, I feel embarrassed. It's like, it's nothing to be embarrassed about. This happens. Like, you think you're all, I've clicked so much stupid. It's like, so that's why I always try to like look at it from the perspective of, like, again, like get this as an interesting, or like you were saying, like a marketing campaign, very spammy. It's like, there's a lot of great opportunities for this. And that made me think about like, so should anyone just be generally concerned about this discovery that you've made? Like, is there any like area we should go, we should alert something or bring this to attention of somewhere?
I mean, I would say we should definitely be aware of it. I don't know if there's one singular place to bring attention to it. I would encourage anybody, who happens to see this at your organization, keep this in mind, because what this essentially means is you can't base too much of your security policy off of file type. It means if you are relying on your proxy to keep keep your users from downloading bad files, or even as we saw, they're not consciously downloading them. They're visiting a website that happens to have a picture that has this encoded in it. And I mean, you can get very fancy with this. For instance, the site that we went to, there were visibly apparent images. You can make just in the HTML, you can make an image not visible to the human eye. You can hide, thousands of images on a page. You could basically encode an entire application into various files and extract them, build an entire application structure on a machine from a browser cache, and do all kinds of stuff with that. Like, so yeah, I would say, like it's still a good, it's still beneficial to have those policies in place, but you need to make sure that you are not relying on them too heavily or taking them too seriously, because, one, a lot of proxies, you can fool them just by changing the file extension. And that's simply a fact, which is ridiculous to me, because they're way too expensive to be fooled by something that trivial, but a lot of them are. But even if they are smart enough to look at, a little bit more deeply, this is going to fool them. So, and this technique is in use by threat actors. It doesn't currently seem to be super widespread as a way of getting malicious code onto a network. It's very frequently used for exfiltration, which is another way to think of, another thing to think about. If you are relying on spotting somebody uploading like an archive, if that is your, the way that you're trying to detect exfiltration attempts, this is a very easy way to get around that. A person can zip up, your entire database. They can stick it to the end of an image, and they can upload that image to, the company picnic site or whatever. The attacker can then visit that site, download the image, and then rip the contents that they just exfilled out of the image.
So this is my idea. Like, okay, so as a way of defense for, like, let's say blue team, and maybe I'm just really dumb and don't actually understand this well enough yet, but one of the better methods for pretty much protecting yourself is, if you're going to be an organization, disable the ability to actually have any caching for a browser, since this is kind of going through that method.
Browser cache is, I think, a very promising kind of attack surface that, is nice. Basically, anything that doesn't require the user to specifically do something, like I tend to like those sorts of things because I don't know, kind of like I said, my area of focus tends to be how people use technology, and that's a very kind of good way to sort of exploit that. Like even a pretty sophisticated IT professional, they're not gonna perceive visiting a web page as downloading a bunch of files. Like, I mean, they might be conscious. Okay, if I go to a web page and I'm running like a really, an unpatched browser, like drive-by downloads are a thing, or like they might think of it in those terms. But what they're not thinking about is simply by touching this website in a browser, like I could download 1,000 files that I don't see with my eyes. Now, if you're looking through network logs, it is going to stand right out. That like this is only going to fool people from a certain perspective, but a lot of people are going to make it will be very easy for them to make assumptions about what has happened that we are deliberately misleading, and that's kind of the basis of this attack. We're leading people to expect one thing while doing something else.
So I was going to get into some more personal questions based on what you shared earlier in the presentation. Get like kind of just more about you because we're getting close to the hour, but I wanted to kind of give Brian an opportunity. Brian, I've just kind of smothered the question areas. It's up to you now if you have anything.
I had a couple of questions and they were largely addressed or mostly addressed. I'll ask them anyway, just for thoroughness.
Sure.
So it seems to me like maybe the most effective way to pull this off would be, I guess, what they call like a watering hole attack, or would you say like phishing is more prominent for something like this?
Well, the tricky part is like watering hole for distributing like the spiked images or basically the secondary payload, I guess we can call it. I don't want to focus too much on images because once again, this could be anything. Images are nice because browsers cache them, but this technique is more broad than that. So I do want to make sure to say that. But yeah, as far as that goes, yeah, watering hole is a great way to distribute kind of your spiked malicious code because you can put that literally anywhere.
Yeah.
You can, because you're marking it with a key that is going to be very difficult to discern its meaning in isolation.
Right.
Over time, like somebody might discover, oh, okay, like this key is a signature that this particular dropper is looking for. They might start to work that out, but like I said, it's easy to swap out the keys. You can include as many keys as you want in your dropper, so you can look for whatever variants you want. And you can put them in all kinds of stuff. You can put them in images. You can upload music files that contain them, or you can upload counterfeit copies of all of these things. That's another thing. There's a popular song. Stick it to the end of an MP3 of that song, and then just send that out into the world.
Right.
And you won't necessarily be able to control where it goes, but you will know that it can be very, very widespread, and it will be very difficult to root out.
Yeah.
The dropper component is a little trickier though, because that does need to be something that will run code on the machine. So I would say, the focus for that one, it needs to be on putting it in a more innocuous form, I think.
And the other question I had, you kind of addressed too. So I work in the GRC side of things, and so I try to think about, what controls can we put into place, right? Like, obviously policy and stuff like that. But I was trying to think, something like this, where you could, get an image file in your cache. To me, the thing that came to mind was like Tripwire. Like Tripwire is going to be monitoring your MD, well, your hashes. But I think like a lot of people probably don't run Tripwire on their entire system, right? Because like particularly browser cache, right, is changing so frequently. You're not going to be monitoring that most likely.
it's going to blow up. Like
Yeah.
you're going to get flooded and you're just going to ignore it.
Yeah. So, yeah, I was going to ask your opinion. Like, what is a a good way to kind of defend against this from happening? It doesn't seem like there really is a great way.
Yeah, I mean, defending it against the dropper is one component, but the variability of it makes that difficult.
Right.
When the code does execute, like I would say the defense against this is going to rely on your endpoint security.
Sure.
Because, when the code starts running, if it starts doing something suspicious, ideally your endpoint should catch that.
Okay.
But it may not, or unfortunately with a lot of this stuff, in a large corporate environment, there often is a lag. And oftentimes an attacker only needs their secondary payload on the machine for a moment in order to execute it.
Right.
And then even if the endpoint protection solution does eventually recognize the file as malicious, a lot of times the file has already been deleted by the cleanup script.
Yeah. Yeah.
So yeah, that is definitely a challenge. Yeah, I guess. I tried to find something that would be difficult to defend.
Right.
I'm kind of in the course of trying to think about that myself. Just kind of my role in my my current organization. I am aware that there are some adversaries that are making use of this, so I'm very much motivated to find kind of things that we can do to try to control against that as well. Yeah, I would say this is why like a layered approach is certainly important to security. That's why I would say like if anybody out there who is relying on some particular stage in this heavily, you should don't rely on your proxy to keep malicious code off. You're going to need a good proxy, and you are going to need a good endpoint solution, because this will probably get through at least some of that. And then also, it's important to make sure that you have forensic capacity as well, because a lot of this stuff, it's with forensics after the fact, you'll be able to piece together what happened, and from that point, you can kind of start to get ahead of the game. But yeah, if you don't have that, it will be probably very mysterious what happened.
Right.
So, since we're kind of wrapping up, getting to our hour here, there's a couple of things that you mentioned earlier in the presentation, personally about you. And so I just figured we should just kind of cover those things, because it's fun. And so, for example, you mentioned karaoke, you enjoy doing singing. So what's either your favorite song or band that you like to work with?
So it's generally against my policy to declare favorites, and I like to surprise people. But I will say a very common song that I sing for karaoke, if I want to be silly, or usually for the first song of the night, I like I Believe in a Thing Called Love by The Darkness.
Yeah, that's good.
It's funny. I have a pretty deep voice these days, but when I was a kid, I had a very like chirpy voice, and when my voice started changing, I went through a very undignified period. But I did find that I was able to sort of retain a high upper register, and I'd learned to sing in it pretty well, and that song flatters that. If I want to make people weep, like if it's late in the night and people are getting drunk and depressed or whatever, and I want to just bum everybody out, there's this Tom Waits song. It's called "Shiver Me Timbers" that I really like to sing. It makes people feel very forlorn.
Yeah. What always gets my Niagara Falls going is just Eddie Vedder, from Pearl Jam, singing what is that? It's called Where Oh Where My Baby Gone or something. I can't remember the song's name, but it's like whenever that's gone, and even the Spanish version makes me go, oh my god, oh. Okay, we need a timeout. I need to collect myself. I'm losing it.
There's a lot of good choices. I tend to favor upbeat stuff. I feel like a lot of karaoke places they become a succession of like slow songs because everybody wants to sing like to their significant other or whatever.
Yeah.
So yeah, I like to try to kick it up a notch as much as possible. But yeah.
Well, I'm the most shittiest singer of this group, so I look forward to joining everybody in karaoke. I will be, and if we're just like, don't give them the mic, I'm a great background dancer. I mean, I'm just saying, I've got some moves. They look terrible. They're awful.
Awesome, man.
But it's me, just doing I call it art, so it's okay.
Awesome, man. I can't wait.
What's your favorite tabletop game? Because you mentioned also you've created like one or two, so.
Yeah, so my favorite one is I would have to say the Legend of the Five Rings RPG. It's a pretty old one. But it's a samurai themed one.
Oh yeah.
Yeah, awesome setting. What the thing that I probably love the most about it, in the early version of it, it's a samurai game, so it's based very heavily on like a bunch of different clans, and each clan kind of has like its own sort of personality archetype or whatever. But one of the cool things they did was each clan was basically authored by a different person. So they basically had a person fully dedicated to each one of these clans, and it was a different person for each one. So the game setting and content is just a lot richer because like any individual person, they're going to have their favorite clan, and they're going to emphasize that one, and they're going to they're like one perspective can only be so broad. So by having basically each person be in charge of their own clan, they can make it the best they can. They can bring all of their life experiences to try to make it as rich as they can. It really shows. Like the setting is just really cool and really fun.
That is so sweet. Yeah. Sorry about that. I was told I was getting a little bit of echo. Sorry about that. I'll try to mute when I speak.
No worries.
I didn't. Actually unmute, so I'll try to, and if it's probably me just with probably getting feedback through the mic, so I will fix that. So thank you for noticing that. The only other question I have, or actually two, but have you ever heard of Critical Role, the podcast group? I love those guys.
Yep.
Yeah, they're fantastic. And if people wanted to connect with you and you're comfortable with it, what is the most comfortable way of connecting with you?
It's a good question. I'm not super active on social media. Let's see. I would say probably the best way would be on Twitter. Just because I monitor that pretty much all day. A lot of the intel feeds that I monitor come through there. So I'm paying close attention to that. If contacted on Twitter, I will probably divert to another format, in order to have a better conversation. Because, Twitter is great for news. I don't like it for conversations at all, though. But that's definitely a good way to get my attention.
Yeah, and I'd like to apologize for the echo that I had earlier. And what I can do is I can make sure that, because I have your, thanks guys, I appreciate that. It seems to be fixed now when I unmuted my big mouth. What I will do is I'll make sure to share in the YouTube channel, but I do have it on Twitter as well, as where I pinned it, that we've got your @ handle. It's at HELMUTYE0. And that's how you can follow Jason on Twitter. All right. Well, we're definitely coming into the little over an hour. Is there anything else you'd like to add, Jason or Brian?
I'm all good. I just want to say thanks, Jason, for coming out and doing this. It was an awesome presentation and cool to learn a little bit more about you. You've got some interesting tastes. I'd love a chance to catch up with you sometime.
Yeah, definitely. Thank you so much for the opportunity. I love getting to talk at things like this. It was good motivation to kind of fully realize this a little bit more. And if anybody does think of any interesting use cases or sees anything related to this, I would love to hear about it.
Awesome. Thanks everyone for the opportunity and the presentation tonight. I'm going to just move on to end the podcast. Thanks everybody. Have a good night.
Awesome. Thank you so much. Take care, folks.